Good morning students. Welcome to my YouTube channel. In this video, I will be discussing on different types of modes of operation in cryptography. So we have 5 different types of modes of operation, that is ECB, electronic codebook, CBC, that is cipher block chaining, then CFB, that is cipher feedback, OFB, outer feedback, and CTR means counter method. Among these 5, the first two, that is ECB and CBC, are known as block cipher modes of operation, and the remaining we call it as stream cipher technique they will use. So now let us see one by one. So electronic codebook mode. So in this, as I told you, it is a block cipher mode. The plain text has been divided into blocks. So here you can see the first block, that is P1 plain text 1 with a number of bits is just encrypted with the key. Please keep in mind this size and the key size should be same. If it is 8 bits, you have divided each block, then the key size should also be 8. So plain text of the first block is encrypted with the key. Then you will get same bits of ciphertext. Then take the second block, do the same encryption with the key, you will get ciphertext 2. Like that you can do till the last block. Here I will given the step. So you are going to get the ciphertext, just you encrypt the plain text with the help of key. So encrypt the plain text with the help of key, you will get back your ciphertext. This is normal traditional method. Okay? In case of decryption, take the first ciphertext, C1, first block of ciphertext, decrypt with the key, then you will get back your first block of ciphertext, plain text of first block. Again take the second block of ciphertext, do the decryption with the same key, you will get the second block of plain text. Like that you can do all ciphertext converted back into your plain text. So this is known as electronic codebook. So the second technique is cipher block chaining mode. So in this what happens, take the first block of plain text, encrypt with the key as we have done in the previous technique, you will get the first ciphertext. Okay, take the second block of plain text, encrypt with the, or before going for encryption, do the XOR operation with the previous ciphertext. Then whatever the output you are getting, do the encryption with the key. Then you will get what is known as ciphertext 2. Hope so it is clear. Once again I am telling, take the first block of plain text, do the encryption with the key, you will get first block of ciphertext. Then take the second block of plain text, do the XOR operation with the first ciphertext, first block of ciphertext. Then whatever the output you are getting, do the encryption with the key, then you will get back your second block of ciphertext. Then repeat the same process. Now what you can do, take the third block of plain text, do the XOR operation with the second block of ciphertext. Whatever the output you are getting, do the encryption with the key, then you will get third block of ciphertext. Repeat the same process until all the plain text blocks are converted into ciphertext blocks. So this is what encryption technique. Here one more important thing is, see, every time we are doing XOR operation with the previous ciphertext, but in case of first block of plain text we don't have any ciphertext. For that sake we are doing XOR operation with the assumed initial vector. Okay, you can assume any initial vector, do the XOR operation with the first block of plain text and do the encryption with the key to get back your ciphertext. Then this ciphertext can be taken as input to the next steps, that is n-1. So here is the clear thing. So if you want to get the ciphertext, what you should do first, take the block of plain text, do the XOR operation with the previous block of ciphertext, that is n-1, i-1, and whatever the output you are getting, do the encryption with the key. Then you will get back your ciphertext. But for initial plain text block, you need to do the XOR operation with your assumed initialization vector to get back your first block of ciphertext. Okay. So decryption is the same. So whatever the first block of ciphertext you got, okay, do the decryption with the key. So whatever the output you are getting, do the XOR operation with the initial vector that you are going to assume. Then you will get back your first block of plain text. Then to get back the second block of plain text, take the second block of ciphertext, do the decryption with the key. Whatever the output you are getting, do the XOR operation with the previous ciphertext. You will get back your plain text. Repeat the same process until you get all the plain text blocks. So hope you understood the cipher block chaining mode. Now let us go for output feedback mode. Okay. So in this what happens? Here we are going to encrypt the plain text to get back your ciphertext. So this is the initial methods we have to do. What we have to do? First you need to assume the initialization vector of n bits, any number of bits. So this I will call it as n bits. Just for example, I will assume like 20 bits as my initialization vector. I will do the complete 20 bits or n bits, do the encryption with the same bits of key, 20 bits. Then you will get the output as 20 bits. So in that 20 bits, what I will do? I will take only n minus 8 bits. For example, if this is your n bits what you got, I will take only n minus s bits. These are my s bits you think. Okay. Then this will be your n minus s bits. So what I am trying to tell, if I take this as 8 bits, then this will be remaining n minus 8. So 20 minus 8 is 12 bits. So whatever the bits you have taken here, s bits, okay, it should be your block size of plain text. Same block size you should take. If I have taken this as 8 bits, normally we will take 8 bits, you can take any number of bits, and this should also be 8 bits. Please keep in mind. Okay. So what I will do now, this n minus bits I will eliminate. I don't want this. Only I will take this s bits and I will do the XOR operation with the first block of same bits, 8 bits. Then you will get the output as ciphertext as 8 bits. That is nothing but s bits. Okay. So this is how you need to get the first block of ciphertext. So what I did, I assumed n bits, example 20 bits, and I have done encryption with the key. So whatever the output I got, 20 bits, I have taken only s bits from that. Remaining n minus 8 bits are removed. Using those s bits, I have taken the same r bits of first block of ciphertext and I have done the XOR operation. Then you will get the first block of ciphertext. Repeat the same process. Again, I have taken the same 20 bits in the second step. Okay. I will do the XOR operation, what I call that. But here, in 20 bits, what I will do? Starting itself, I will take s bits, what I am getting output here. Here you can see. These are the s bits which I have taken, no 8 bits. Same 8 bits I have taken here as the starting step itself. So these are nothing but your s bits. Then these are nothing but n minus s bits. Okay. If we are assuming 20 bits, in that 20 bits, the n minus 8 bits should be your previous output. Okay. Remaining 16 bits, you can assume whatever you want. So in the next step, I will do the complete encryption with the key. Then you will get what? N minus 8 bits, s bits as well as s bits. So now again, I will not consider n minus 8 bits. I will consider only the s bits and I will do the XOR operation with the same bits of plain text 2 to get back my ciphertext 2. Okay, repeat the same process until all the blocks of ciphertext are obtained. So hope you understood. But here, so instead of taking this as the r bits as the input to the next step, I will take now Ciphertext, whatever you are getting here, after doing the XOR operation with these OR bits and plain text of these OR bits, so you will get now OR bits of first ciphertext. This I will take as the input now to this S bits. Remaining n minus s bits will be as it is. So instead of taking the output of this, I will take the ciphertext as the input. So that technique we call it as a cipher feedback mode. Remaining everything is same. Same process. Assume n bits, do the encryption with the key, then you will get n bits of output. In that I will take only the s bits. Remaining n minus s bits I will not consider, and I will do the s bits with the or bits of first block of plain text. Then you will get first block of ciphertext. This first block of ciphertext I will take now as the input for this s bits. Remaining n minus s bits will be user defined or assumed value. So I will do the encryption everything. Then I will get s bits and n minus s bits. N minus s bits I will not consider, and these s bits and the or bits when I do the XOR operation, then I will get the second block of ciphertext and repeat the same process. So instead of taking this output as the input to the next step, I am taking the ciphertext as the input to the next step. So this is about cipher feedback mode. Next we have counter method. So this is very simple. Again same, assume the n bits whichever you want, that is the initialization vector. Do the encryption with the same bits of key, then whatever the output you are getting now, do the XOR operation with the first block of plain text with the same number of bits, then you will get the first block of ciphertext. Repeat the process. Next time, whenever, if you assumed here 10 as the initialization vector, now you need to assume counter plus 1, that is 11 as the initialization vector. Repeat the same process. If 11 you are taking it as a representing as 10 bits like 0, 0, 0, 0, 1, 0, 0, 1, something like that, then again do the encryption with the same bits of key, you will get the output, do the XOR operation with the second block of plain text, then you will get the second block of ciphertext. Repeat the same process. Then for the next step, you need to take 12, means counter plus 1. It will go on incrementing, counter plus 2, counter plus 3, like that. So until you get all the blocks of ciphertext. Okay. So these are the 5 important cipher modes of operation. Hope so you understood the techniques. Now we will go for the assignment. So viewers are informed to put the solution for the assignments in the comment box. Okay. So these are the possible questions, assignment questions you may get. Okay. First one, define what a cipher mode of operation is. What does it mean first of all, and why it is useful. Second, describe why modes of operation are necessary for block ciphers. Third, list and briefly explain 5 common cipher modes of operation like electronic codebook, cipher blockchaining, cipher feedback mode, output feedback mode, and also counter methods. Next, provide one advantage and disadvantage of each mode. Then very important, this is project based. Encrypt the plaintext hello world using a simple block cipher in ECB and CBC modes. Here we can assume the block size as 5 characters and the initialization vector as ABCDE for CBC mode. Next, discuss how the ciphertext changes in both modes when a small change is made in the plaintext. So how the effect will be. We call it as avalanche effect. You just browse this information more about this. And lastly, explain which mode is more secure and why. So all these assignment questions will be dropped in the description box. So you can post your comments in the comment box. Okay. So hope you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.